All right, let's get right into it. We all talk about the cloud constantly, right? But what is the actual, thing that makes it all tick? Well, today we're going to pull back the curtain on the secret engine that is literally powering our entire digital world.
And that's the big question, isn't it? We use it for everything, streaming movies, storing our family photos, running our businesses. But if you really try to explain what it is, it gets kind of fuzzy, a little abstract. So what's the real story?
First off, let's just get this out of the way. It has nothing to do with actual clouds in the sky. It's really a revolutionary idea, a whole new way of thinking about computing. And it's all built on the back of one single, incredibly powerful technology. And that technology is called virtualization.
So, that brings us to the absolute heart of what we're talking about today. We're going to unpack this hidden engine and see exactly how it's running the show from behind the scenes.
So, what is virtualization? Well, at its core, it's basically the art of illusion. It's all about using clever software to create a digital copy, a virtual version of a real physical thing. This could be an entire computer, a big storage drive, or even a whole network. It's the magic trick that breaks the link between software and the specific hardware it's supposed to run on.
Now, to really wrap your head around this, you gotta see how virtualization lets one single physical computer pretend to be a whole bunch of different machines all at once. So let's look at the basic setup.
I love this analogy. Think about it like an apartment building. The physical computer, the metal box, that's the building itself. Then you have this special piece of software called a hypervisor. Think of it as the building manager. Its job is to carve up all the building's resources, the electricity, the plumbing, and create individual private apartments. Those apartments are the virtual machines, or VMs. And inside each one, an operating system can live, totally separate, completely unaware of its neighbors next door.
So this is the key takeaway here. The hypervisor is the secret sauce. It's the magic layer of software that sits in the middle, managing everything. It lets one beefy computer act like dozens of smaller, completely separate and isolated computers. Without the hypervisor, none of this works.
Okay, but not all hypervisors do their job in the exact same way. It turns out there are two main approaches to creating these virtual worlds, and the difference between them is, well, it's pretty fascinating.
You've got full virtualization, which I like to call the great pretender, because it totally fools the operating system. And then you have paravirtualization, which is more like the willing collaborator, where the OS is actually in on the whole act. Let's break them down.
Okay, so with full virtualization, the hypervisor creates this absolutely perfect one-to-one digital replica of a computer. So the operating system running inside it, let's say it's Windows, it is completely standard, totally unmodified, it has absolutely no idea it's living inside a simulation. This is amazing for security and for running older programs, but creating that perfect illusion takes work, which adds a little bit of performance overhead.
Paravirtualization, on the other hand, takes a totally different path. In this world, the operating system knows it's virtual. It's been specially modified to cooperate directly with the hypervisor. So instead of trying to talk to fake hardware, it makes these direct, efficient requests called hypercalls. It's like teamwork, right? This cuts down on the overhead and really boosts performance. The only catch? You can only run operating systems that have been specifically modified to do this.
But here's the thing. Virtualization is so much bigger than just running a bunch of operating systems on one server. The concept itself is way more flexible. Let's look at some other places it pops up. How about application virtualization? This is where you package up a single program, maybe an old piece of software, with everything it could possibly need to run. It all gets bundled together and lives in its own little self-contained bubble, completely isolated from the main computer's operating system.
And why on earth would you do this? Well, imagine your company has this one critical app that it absolutely relies on, but it only runs on, say, Windows XP. You can't just get rid of it, but you need to run a modern, secure computer. Well, this is the solution. Application virtualization lets that ancient app run happily inside its little bubble right on top of your brand new Windows 11 machine. Problem solved.
You can do the same thing with storage. Picture a huge data center with hundreds of different hard drives all over the place. Instead of trying to manage each one individually, which would be a nightmare, storage virtualization just pools them all together. To your computer, it just looks like one giant, seamless hard drive. This makes managing data, doing backups, and moving things around 1,000 times easier. And you guessed it, we can virtualize the network itself. We can take all that physical hardware, the switches, the routers, all the cables, and use software to create completely virtual networks that run right on top of them. This gives you this incredible flexibility to design and secure networks however you want, all with just a few clicks.
And a perfect everyday example of this, a VPN, a virtual private network. A lot of us use these every single day. A VPN uses network virtualization to create a totally secure encrypted tunnel over the public internet, making it seem like your laptop at the coffee shop is sitting right there on your secure office network. That's it in action.
Okay, so let's take a step back. We've got virtual computers, we've got virtual storage, and we've got virtual networks. When you start putting all of these incredible, flexible building blocks together, well, that's when you get the foundation of the entire modern internet. You get the cloud.
See, cloud providers take all these virtualized resources and they package them up for us in a few different ways. First, you have IaaS, or Infrastructure as a Service. This is like renting the raw virtual building blocks, the servers, the storage, the networks. Then you've got PaaS, Platform as a Service. This gives developers a ready-made workshop to build and run their apps without having to worry about what's underneath. And finally, there's SaaS, Software as a Service. This is what most of us use every day. Think Gmail or Office 365. You're just renting the finished, ready-to-use application.
And the way all these cloud apps are built now is often based on something called service-oriented architecture. Instead of building one giant clunky program, developers build apps out of lots of smaller, independent services that all talk to each other. Think of it like building with Lego bricks instead of carving something from a single block of wood. It's just way more flexible and resilient, a perfect fit for the virtual world.
Now look, as amazing and powerful as this technology is, it's not a silver bullet. It's not perfect. There's a really important trade-off that you always have to keep in mind.
So on the one hand, the advantages are just massive. You have server consolidation, which means you can maybe replace 10 physical machines with just one. That's a huge cut in hardware costs, and you get amazing scalability and reliability. But on the other side of the coin, you always have that small performance hit from the extra software layer. It also adds complexity, and if you don't set it up right, it can become a real headache. But for most situations, the incredible gains in cost and flexibility are more than worth it.
At the end of the day, though, the benefits are pretty undeniable. I think this quote from our source material really nails it. Virtualization is what gives the cloud its superpowers. It's what allows it to be so efficient with resources, to perform at a massive scale, and to give us all the incredible flexibility that we now just kind of take for granted.
So, we've seen how virtualization completely rewrote the rules by severing that ancient link between a piece of software and the specific physical machine it had to run on. It was a massive shift in how we think about computers. And that just leaves us with one final big question. What's the next chain, the next unbreakable link that this powerful idea is going to snap into?